Hello everyone. So my name is R. Surya. I'm currently pursuing undergraduate in Savita Engineering College in the AI-based department. So in this video, we are going to see about how to implement MLP, multi-layer perceptron using Python to solve some real-world problems. So we are going to mainly focus on using MLP to solve XOR problems in this video. So let's dive into it. When considering XOR truth table, there will be two inputs, zeros and ones of binary values. So while considering about them, if both the values of the inputs are zero, the output will turn to be zero. If both the values are turned to be one, the output will be zero. So the same mannerism. If both the values are same, the output will be zero. Otherwise, if in case any other value is going to be different from one another, where x1 is not equal to x2, the output will be turned as one. So like this, we are going to map this in a graph or plot this in a graph, and we are going to try to separate both of them from different each other, we'll face complexity. Like we can't able to separate them as we need it. So we are going to solve this using MLP by increasing the dimensionality in the problem, and let's separate it from one another. So we are going to see that in Google column, which is termed as experiment 3. The title of the experiment 3 is multi-level perceptron and non-linear separable data. So let's see the code. Let's start the implementations by importing the major libraries that we use in Google Colab, naming such as NumPy and Pandas. We are going to rate them as NP and PD as so on going further. So let's decode the code. So there are major two libraries as I mentioned earlier, NumPy and Pandas. And we are going to import the math workflow that PyPower plus PLT. So basic upon this problem, we definitely need two inputs. So they are being we have been already predefined it as 0, 0, 1, 1, 0, 1, 0, 0 and y as 0, 1, 1, 0. We can also get the input from the users as well. We are just defining it with the np.array function, which is useful for the compiler to make them into an array. So moving on further, we are going to term four variables n of x, n of y, n of h, and so on. So we are going to input the same as we are going to change the weight as well in the forward propagation. We will be changing the addition and sum of the products of the vectors, and we will be determining the output using the activation functions. While coming through the backward propagation, we will be calculating the gradient, and using the gradient, we will be in order to find the gradient, we have to find the local gradient. After finding the local gradient, we'll be proceeding on to finding the gradient. To finding out the gradient due to the back propagation, we will be adjusting the weight as such. It will be changing the network to get an optimal outcome. So we have been using that sigmoid function. So z of 1 divided by 1 plus np dot exponential of w1 comma x. So using the sigmoid function is being used as an activation function in the forward propagation. So what are the operations that are going to be taken place in the forward propagation? It has been defined as a function in forward prop, where comparing to the backward propagation, the same way, what are the functions and the activities that are going to take place in the backward propagation are being listed in a very known manner using the different formulas, np dot shape. These formulas have been playing a major role in completing the backward and the forward propagations in the XOR problem. So here the next one that is being implemented is the iteration. So the epoch or the iteration is the number of times that the system has to run itself to get the optimal outcome. It can be varied from system to system. The more time the epoch runs, we can understand the system so well. So there is another defect of running the system more than thrice or twice has been expected, because if the system runs over and over time, it may overfit the problem. That means it will be like entering into the memorizing effect. So in order to solve such problems, we will be setting as an iteration that predicts and gives us the maximum output in an optimal manner. So we are going into the loop for in range of iterations. So the number of iterations, it will be running that lines in the code as much as possible. After running the program of the defined codes with the mathematical expressions, all the mathematical expressions have been given in the description. You can have a check. So after that, we are going to find out the loss and the epochs that we run during the field. So we are using the graph visualization. So we have plot the x and y graph with the linear linear separable method. So using this, we have increased the dimensionality, and we have successfully separated the two values which has been producing with the zeros and one. Ex- uh, repres- uh, representatively. So hence we can be so clear that we can see that 0, 1, 1, 0, 1, 1, 0, 1, 0, 0 are the inputs of XOR gate, and the outputs are termed to be provided as we require. So hence we can conclude that the MLP, which is multi-layer perceptron, is useful in solving any complex and which is not been separated using linear separable method, can be separated using improving the dimensionality and non-linear separable methods also. So this is what I came to convey in this video. So thanks for watching. And that's